All right. So again, you have the whole breakdown, the rubric and all that stuff. Some overviews. If you go to tech assignment C, now you see the again the spiel, but then you create a Google account if you don't already have one. Don't already have one. I'm tripping over myself now. Work through the assignment, which is tech assignment C, CLT. Now, when you open it, at least for the time being, it's going to say tech assignment B, but it is still it is the correct one, right? CLT for central limit theorem. Watch the video on central limit theorem just to get a sense of what this whole thing is all about. A little bit of a refresher. And then, the discussion prompt, that should already be up. I set that to be released at 8 p.m. But yeah, that'll be there. So click on Tech Assignment C, Central Limit Theorem. And you see that you have this whole breakdown here. All right, it's very, very procedural, and you see lots of references to Tech Assignment B, which I think is why I put this whole thing off for so long. And I had every intention of doing it, and then I just didn't. All right, and again, I have this little link here telling you that there's a video. The problem is, if you do it in this interface, I mean, if you download the PDF, I don't want to say it'll definitely work, but I remember it working. That this is the same video that I have in the main page for the tech assignment, so you don't have to watch a second video. All right, so you're gonna do a couple of things. You're gonna simulate a die, all right, a single die simulation. So a roll of a die. So, die is in singular for dice. All right, you go to Google Sheets, sign in, create a file. In this case, again, another reference to tech assignment B, but it is a tech assignment C situation. All right. This thing is out. Another thing that I meant to change. So this is irrelevant. I'll put an updated one up here sooner rather than later, but I didn't want to put off the overview any longer. All right. Let me just walk you through at least the meat and potatoes of it. Now, when it comes to your final response, you see all these questions here? I'm going to have a Google form for you to complete. All right, so you'll be able to put everything into one place just like you did for the last tech assignment. So that'll be there for you, and I'll put that as a separate link. All right, so just wait for an announcement on that. All right, but as far as the assignment is concerned, what we're doing is rolling a die 500 times, which sounds like it would be troublesome, but it's really not that bad. And then we're going to create a frequency histogram, all right, a frequency histogram to display the information, all right. So there's a lot of different bits and pieces that go into this, but it's actually, it's not that difficult if you follow the steps, right? So I'm just going to take you through it because the heart of this assignment is really the interpretation and the analysis at the end of it. All right, so let me get my spreadsheet open. The first thing you're going to do is you're going to type in an equal sign to indicate that what you're about to put in is a mathematical equation or an expression that requires computation. All right, so what we do is rand between. All right, different platforms use different verbiage, but rand between. And the die has outcomes between 1 and 6. All right, so rand between 1, 6, close parentheses, equal sign's got to be there, hit enter, and what it'll do is it'll create a random selection, a random value. And so all you'd have to do is copy, so Control C or Command C, depending on which device you're using. Highlight down to 500. Almost there. And then Command V, Control V, whatever. All right. You could also drag that lower corner. It works better on Excel if you do that. Like if you were to just drag that down, it'll just autofill. But I've had enough people struggling with that that I kind of shy away from explaining it that way. All right. But let's say I start typing in something over here. Let's say I type in a 5. You'll notice how the random integers changed. Okay. Very important. Your numbers are going to constantly change on you because these are random. That's intentional. All right. I want these numbers to fluctuate. All right. I don't want them to be fixed. I don't want them to be static. I want them to be ever changing. So every time you type something in, you're going to see a change here. That's normal. All right. That's to be expected. All right. Oh, wrong thing. So that's the first part of it. Very, very straightforward. Should be easy enough to do. All right. We want a histogram. So in order to get a histogram, very, very straightforward. You can highlight the information if you want first, or you can do it after the fact. Actually, it doesn't really matter. But it's insert chart. Chart type is the histogram chart. All right. So insert chart. Oop, it slid over on me. Chart. Then you could see here under chart type, under the setup, customize, you start getting into other aspects of it. You have these different options here. And you see, if you scroll down under other, you see an option for a histogram chart. All right. So the data range is the important thing, right? Because right now I haven't told it anything except for whatever cell I had highlighted before I even got started. All right, so I could do it a couple of ways. One would be to get into this data range and just kind of highlight all these values after the fact. Another way would be to actually type it in, not the individual values. If you don't have experience with Sheets or Excel, you probably just had a moment where you didn't find that amusing. All right. So you'd highlight the values, insert, chart, and then you could see that it included the values from A1 to A500, right? So that's how we denote references to columns and rows in Excel, column first, then row. So A1, column A, row 1, the colon is telling us that we're going all the way to 100. I'm sorry, 500. All right. So you'll see here that, when I clicked out, it took me out of the whole editor. What I would want to do, I can do a couple of things. I mean, I could go back into chart style. I could do this, I could just kind of pick or choose. But if I hit data range, that'll get me back to where I was. All right. So we want to customize this because I'm looking at these data points here as being whole number values from 1 to 6, but I'm seeing a whole bunch of decimals here. Those aren't working for me. So you go to customize, and you have all these different options, and if you're ever in doubt, just work your way down the line. And in some cases, you can kind of have some fun with it, chart border color and things like that. I'm not overly concerned with that, but some people like to spend some time on that. If you go under histogram, you see show item dividers. If you click on that, it'll divide up your bars. I don't know how interested I know I'm not interested in that, but I don't know how interested you'd be in that. The one that's really important here is the bucket size. Bucket, bin, intervals all mean the same thing. This is talking about how wide you want each bar to be. All right. I don't want Google Sheets or Excel deciding that for me. I want to decide that myself. Right. So in the drop down here, I'm going to select 1. Right. So that's going to make it go integer by integer. All right. So it's telling us that we have 6 bars, all roughly in the same neighborhood of the same height, give or take a little bit, but they're all kind of living in the same neighborhood. But now I know the number of 1s I had corresponding to this bar, the number of 2s, 3s, 4s, 5s, and 6s. All right. Now it goes up to 6.5, so it's kind of weird, but that's okay. All right, as long as you have 6 bars out of it, you're good. All right. If you wanted to, I mean, you could go by twos, but then you see now it's compressing it all. So all the values between 1 and 3 are together. That doesn't make sense for our purposes. All right. Now, under chart and axis titles, right? The chart title, you know, that we're talking about a histogram, right? So that's great, but it's for specifically the roll of a die, right? So all of this stuff here, you know, is really kind of getting at that information. But as far as the overall title of it, I mean, you could just leave it as histogram, but you do want to make sure that you change your horizontal and vertical axes to their appropriate names. Like, for example, the horizontal axis should be outcome, vertical axis should be frequency. All right. So we'll get to that in a second. But if you want to get more specific here, you can too, because it's a really histogram for the roll of one die. All right. So automatically changes at the top. Little drop down here. All right. Under chart and axis titles, drop down, you see horizontal axis title. That's where we would say outcome. See, it changes it to outcome right there. Vertical axis title, that's where we would want it to say frequency. All right. Now, if you want, like I said, if you want to get into playing around with the fonts, that's perfectly fine. Not anything I'm requiring you to do. All right. The series, that's the data points that were selected. Right, so it's representing all the data points that we selected using the color blue. If you want to change the color, you can do that. But like I said, it's really not anything I'm gonna, actually, this kind of looks cool. So I'll leave it like this now. All right, so the legend, all right, so where do you want that information? You know, like the key, any kind of interpretation. You know, in this case, it's irrelevant because we're not dealing with anything that's like a key to interpret the meaning of the values. It's strictly numerical. Horizontal axis, you see again, you're talking about the different types of fonts, but as far as the minimum and maximum values, that's kind of important because now I can toggle this so that it fits the appropriate amount of data. But now you see here, if I say I'm going from 1 to 6, it reduces the number of bars to 5, all right, which doesn't really make much sense because somehow along the way, what they're doing is distinguishing between the different values, but we don't know where that's happening. Is that happening at 1.5, you know, halfway between 1 and 2? You know, so what you can do here is kind of expand a little bit further beyond what you think the interval ought to be, right? And this way there's no uncertainty. Like if you go to a value that you know is less than the lowest number that you have in your set and a value that you know is larger than the highest value that you have in your set, then you know that the appropriate number of bars will be there. So everything in this bar is going to be in the category of 1 but less than 2. So 1s, 2 but less than 3. So all the numbers 2, all the 2s that are in the set, 3s, 4s, 5s, and 6s. All right. Slant labels. I mean, you can have some fun with that if you want. You know, that's again, that's a personalization part of it. That's not anything that I need from you. All right. The vertical axis, again, the minimum, maximum. I don't really see anything wrong with this in terms of how it's counted off. From 0 to 100 by 25s, you know, that seems reasonable. If you wanted to bring it down a little bit because maybe 100's a little too big, you could do that. You don't need a log scale because these numbers aren't that large. Number format, you know, you could change the format, but from source data works here because they're all whole numbers. All right. The grid lines and the ticks. So this is where you can kind of make things a little bit more convenient for yourself, because if you put some major and minor lines in there, then it might be easier to count off values. But in this case, I don't think it's too necessary. Like, for example, if I put minor grid lines in here, See how when I put it in, it puts extra horizontals in there. So now I know, if we're talking 75 and then it's in getting from 75 to 100 in thirds for some reason, each one of these is going to be a little bit more than 8. So you know that you're somewhere, like somewhere short of 83 here, but there's a better way to actually get your counts. Now you could actually change the spacing, right, on the minor counts and mess around with that to make it a little bit more fine. So those minor lines, it's really just telling you how many lines you're going to fit in between the major lines. But I don't think it's necessary to have the minors to begin with. What do they do? I turned off the major grid lines too. Major grid lines, yes. Minor grid lines, not as necessary. Major ticks, maybe, depending. But in this case, I don't think the ticks are adding anything more than what the major lines are doing, right? But the minor ticks could be helpful, so if you want to have a little scale on your vertical axis, you could do it that way. So maybe that's worth keeping, right? So that would be how you would set up a chart. And again, there's only so much of that that's necessary. The rest of it is just personalized, right? So then, and very important, as I change numbers, let's say I put a number 5 in here, and then I delete it. You see how the graph is changing every time I make a change in Excel or Google Sheets. It's changing my graph. That's to be expected. That's normal. We want that fluctuation, right? We want to see lots and lots of fluctuation in our data set. That's part of the plan, right? So that gets you all the way up to number 7. Then, and specifically in these cells in C1 and C2, type in these values. And the reason I'm telling you to do it in these particular cells is because there's some, I'll call it coding for a lack of a better term, but there's some references, row and column references that we're going to make that are specific to particular cells within sheets, right? So you got to be careful about that. All right, so in C1 and C2, we're typing in mean and standard deviation. All right, C1 and C2, mean, standard deviation. See, changes in my graph, that's fine. You'll also see that nothing mathematical is happening because I didn't put an equal sign in front of these things, right? So Google Sheets, Excel, they're not going to expect anything mathematical to happen unless you have an equal sign there. Right, so now we're going to put these commands in. I tried to make it somewhat copy pastable, but if you do it, by clicking, you open up the link and it brings you into this interface. It could be a little tricky. Sometimes it copies, sometimes it doesn't. If it does, great, go with it. If it doesn't, then I would download the PDF and then copy it from the PDF there. All right. So just a quick copy paste. That's why I put the line commands in here. And again, sometimes it's a little glitchy. If you find that it's glitching out on you too much, then just go ahead and download the file. It's not corrupt, I promise. It's not going to put a virus on your computer. Right. So we have a mean and standard deviation. And you're like, oh, 3.416. Let me write that down. Well, don't fall in love with that number, because it just changed. Any other change that you make in the spreadsheet is going to change that number. All right. So this is all part of the plan. All right. So we have step 8 taken care of now. Now, step 9, type sample 1 in cells F1 and F2, and then this command. All right. This is a fun one, but again, try to make it copy pastable, so that it's going to be a little bit more user friendly. So in F1, we're going to type in sample 1, and then in F2, we're going to type in this index command. All right. And so what that's doing is it's creating an index between A1 and A500, all right, based off of just it's a random selection of a value between the numbers 1 and 500. But then once one of those numbers is selected, this command is bringing you to that row in the original A list and pulling that number out. All right. It's happening all behind the scenes. Right. So what it's doing is it's creating a sample from that list. Right. So that would be the first value. All right. Copy and paste this command to fill cells F3 to F11. All right. So F3 to F11. Before I do that, let me just kind of, this is one thing that's always going to be fun is the graph will sometimes be in the way. But if you just do a Control C or Command C, F3 to F11, now you have a sample of values, 10 values that were pulled from this list of data. All right. So that's your first sample. All right. So then in E12, we're going to type in the mean of the sample. All right. The mean of the sample goes in E12. So E12, specifically E12, mean of the sample or sample. All right. If you need to make the cells wider or narrower, that's fine. And then you see, I typed that in and all these numbers change. I must be doing it wrong. No, you're doing it perfectly fine. You're doing it right, I promise. All right. So then you're going to find the average of the values between F2 and F11. All right. So we're finding the mean of these values. All right. So we randomly selected values from this set of data. That's where these numbers came from. The mean of which is this number. All right. So now all we're going to do is, that same process, just, 9 more times. Sounds like fun, right? Super easy, barely an inconvenience. So all you're going to do is copy paste. One too many. So I did that a little quickly. Let me undo that. If you click on the cell, you see that little box in the lower right-hand corner. That's a fill option. All right. So if you drag that to the right, what it's going to do is it's going to change any numerical values to the next consecutive numerical value based on the cells that you're in. All right. So if you go over one cell, it'll change it once. If you go 2 cells, it'll change it twice, 3 times, 4 times, and so on. 5, 6, 7, 8, 9. We want 10 total. I keep doing it. So we don't need that last one. All right. So that, is it necessary that you do that? I mean, if you want to type in sample, then the number 2, then type in sample, then the number 3, then sample, and then the number 4, and then sample, and then the number 5, you're welcome to do that. But isn't this way a little bit easier? I'll even do it one more time. All right. So just undo. I think I only want to go to O here, though. So click on the one you want and just drag it until you fill up all the appropriate spaces. All right. So what I want to do now is copy all this stuff over. So one way I can do that would be just a quick Control or Command C, Control or Command V. All right. You'll see here that all of these values are still the index, random between 1 and 500, referencing A1 to A500, and all the values are the same, all as they should be. But now instead of this referring to F2 to F11, it's now referring to G2, G11. All right. But what you could also do is just populate it through by dragging that little fill icon, and it'll do the same thing. All right. And just verify that it's referring to the right columns, G2 to G11, H2 to H11, I2 to I11, and so on. All right. So now you have all of these sample means, right? So if you think about the central limit theorem, the central limit theorem is telling that when we used an example in the packet that was very simple. It was just 4 numbers. And from those 4 numbers, you sample 2 at a time. Right. And that created a crazy list. Right. That wasn't fun. We had a total of 16 values. We found the mean of each pair, made a list out of that, found the mean of that. And so this gets a little crazy if the numbers get larger and larger. So here, instead of having a sample of only 4 values, population of only 4 values, I just gave you a population of 500 values. You know, it's no easy task, but you follow this process and it'll all work out. All right. So now what we're looking to do in E13 is we're looking for the mean of the sample means. All right. The mean of the sample means. All right. So in E13, I'll get rid of the quotes here. The mean of the sample means. Expand that a little bit, try to make it look nice. What we're trying to get here is the average of all these numbers. Now, this average should be somewhere in the neighborhood of what the average of the mean, average of the sample is. Now, I'm using sample and population interchangeably only because we're rolling a die. You could technically roll a die infinitely many times, but if you roll it enough times, you should get a true sense of what the population mean is. All right. And so based off of 500 trials, approximately, well, in this case, exactly, we're getting a mean of 3.5. The mean of these sample means, each one of these sample means should be somewhere very close to that 3.5. All right. So that's where the next command comes into play. It's the average of F2 to F12, F2 to F12. Geez, I'm making stuff up now. F12 to O12. All right. So here's my F12. Over here is my O12. I'm finding the average of everything in between. So 3.47, the average of everything between F12 and O12. Yeah, that's pretty not bad. And you see my mean over here changed. Oh no, I must be doing something wrong. Oh, it's supposed to change. It's random. All these numbers, you see, they constantly change. Every time I make a change in the spreadsheet, everything's fluctuating. But no matter how many changes I make, this number should never be too far away from that number. All right. Then what we want is the standard deviation of the sample means. All right, so that's going here. All right. And the command for that is standard deviation. Odds are, just like with Desmos, odds are if you start typing in the thing that you're looking for, if Google Sheets or Excel or Desmos can do it, it'll give you some kind of indication that it can. All right. In this case, it's standard deviation. And so you're looking at this and saying, well, that's nowhere near what this number is. Yeah, well, that's part of what the central limit theorem is really talking about. And I can actually kind of sort of steer you in the right direction here, because part of your assignment is to answer these questions. All right. And like I said, this will all be in the tech assignment answer form, which somehow did not also find its way up on the tech assignment, but it will within moments of class ending, because that I have ready to rock and roll. But the sample size here, the number of values in each sample. So I'll just actually make a note of that. Number of values in each sample is it should be it's 10. I mean, that's how it's designed. All right, there's 10 values in each sample. 1, 2, 3, 4, 5, 6, 7, 8, 9, 10. All right, these numbers don't count because these are summary values. All right, they're not actually part of the sample. All right, so what would happen here is if I take this number based on the central limit theorem, if I take the standard deviation, the population standard deviation, that's what these numbers are giving us, and divide it by the square root of this number, I should get something very close to this number. All right, so if I take And we can verify. If I take the population standard deviation divided by the square root of 10, just using some offhand notation here. All right, population standard deviation divided by the square root of 10. And actually, in more general terms, the square root of n. All right, which is what this value would be. Computationally, it's not difficult to do. All you'd have to do is say E equals, and this is not written in the tech assignment, but there's no reason why you can't do it, at least to get a good sense of whether or not you're doing things right. Right? What you would be doing is taking your population standard deviation, which is this number in D2, and dividing that by the square root. Now, you could use the square root function, SQRT, or you could raise it to the 1/2 power. It's really up to you, but SQRT seems to be popular enough, right? And so if you take the square root of F15, which is where we put the n value, you get something like 0.555. Now, this number is about 0.371, right? So it's close, but it's not the same. You know, maybe, you know, I put in another number. You see now it's 0.544, 0.591. The numbers changed. So these values are closer together. So sometimes they're close, sometimes they're not. 0.442, 0.539, 0.700, 0.538. I'm just making up something. Now they're a little closer. Sometimes they're closer, sometimes they're further. All right. The follow-up questions are going to help you kind of think about under what circumstances these numbers will get so close to one another as to be indistinguishable. All right. So that's the idea. We want these numbers to be so close to one another that they're virtually the same. All right. Because we know that these two will be virtually the same based off of our experience with the central limit theorem. I want to know what circumstances will allow these two numbers to be virtually the same. Right. The video is going to help. The resources that I've given you so far should help. But that's the extent of the tech assignment. But you know, me walking through this whole thing for you just kind of de-emphasize the importance of you actually carrying out the process of making the spreadsheet. Yes, I do need you to make the spreadsheet. Yes, you will get full credit for making the spreadsheet, but there's also an amount of credit in this assignment reserved for properly answering those follow-up questions. So you can get full credit for the part of the assignment that requires you to make this spreadsheet. But if you don't do the follow-up questions, or if you half-heartedly do the follow-up questions, you're not going to get a good score on this. Right? So put an honest effort in that too. You know, it's not just a matter of following steps to get an answer. You got to do all the other things too. All right. So let me stop this recording. I'm going to post this up on YouTube.